Alright, let's go. Alright, so I think I sort of get it, but for many multi-operations transactions with multiple keys, you need a database that provides ACID transactions on value versus key, consider versus value versus key. So multiple keys. Okay, so explain the primary use cases for the key value NoSQL database category. Basic CRUD operations like creating, you can create stuff with all your key values. Or for, I think they said user profiles. They said something about web session information. I guess that's also important because that has a hash map key and cart information. However, anything that requires a many-to-many relationship, requires complex queries and joins, such as many-to-many relationships, and those would be recommendation engines because you have to relate to a whole bunch of stuff to make sure to see if you can recommend it, a whole bunch of tables and information. Then you also have, I don't know, social media posts. Yeah, social media posts, because they just, you can't really, you need the value, I guess, which is the hashtag maybe. Oh man, I'm not doing so well. What is the next one? Yeah, for applications that have multiple keys, I think. Oh, wait. So describe the architecture of the key value category of a NoSQL database. Okay, sorry, explain the primary use cases. Well, we've done the primary use cases, I think. It's just you can't really use it for a certain thing, I guess. Not really sure. I lost my train of thought here. Explain the primary use cases for the key value NoSQL database. Wow, I don't know. Okay, so we need ACID transactions when you have to work with many tables. Okay, so I think that's it. Wow, not good performance here for me. Could be better. Could be a lot better. Just have to say that. Oh, so wait. Wait, we got everything right? Wait, we got everything right? We got everything right? What's going on? Okay, so they don't want any examples. Okay, right. NoSQL database categories document. Describe the architecture of the document-based category of NoSQL databases. The document-based. Okay, so it is column. Oh, sorry, it's not. You can create a JSON object. We're familiar with this JSON object, so XML object or Python script with a dictionary, and the values are visible. I think it's quite useful. You can do one document query between them. You can create document collections. You can store many documents. It's very scalable. So you can shard it well because you can put lots of documents in. Well, they can each be in servers and they can be backed up on say 3 servers, and the database has a flexible schema. You don't have to put it in a specific way. All right, very, very nice. So, each piece of data is considered a document. Okay. Horizontally scalable as for sharding. Atomic operation. Okay, we actually got it very, very correct. Now, question 2. Question 2 is explain the primary use cases for the document-based SQL database category. Describe the primary use case. Oh wait, I can't look. Okay, so primary use cases. What can I think of? I can think of events, actions such as tweets, posts, users, likes. What else? What else? I think that's not use cases. We need to query something. The complex query. I don't think complete. It supports complex indexing, not complex querying. As you know, every single document source, every single SQL database data has its own unique primary identifier, apparently. Oh no, we didn't do this. What am I doing? Oh, use cases. So bad. So in NoSQL event logging for apps processes, each event is an instance represented by a new document. Online blogs, post, comment, like, okay. Metadata for web and mobile app designed with the internet in mind, JSON, REST web, and unstructured data. So, operational, with the internet in mind, for NoSQL, unsuitable cases for ACID transactions, can't handle multiple documents. So you can't do multiple documents. That just doesn't work. Relational databases. But you can look at them. I don't think you can actually query them. Okay, if your data is in an aggregate-oriented design, data is naturally left and falls into a normalized data model. Then not to be a mess is better. Okay, so let's just try it. Okay, so now let's explain the primary use case for document-based SQL database category. Okay, so that's like blogs, user likes, comments, posts. I think it's like actions, user events, primary stuff. Okay, also you can't do more than one document. You can't use them. Obviously, you can have a collection, but that just means you can access them in the collection. You can access maybe document to document, but not multiple documents. So sort of 3 documents is too much, but 2 is fine. Or is it just two indexing one and another is too much? That's okay. And if you have it normalized, which means you need multiple multiple documents for each amount. By the way, each document is an event, then you call that I don't know. Each document is a event. Each document has an event. Whoa, what is going on? Each document has an event. Okay, each document is an event, but yeah, if you're trying to normalize and create many duplicates for redundancies, then just the relational database is documents. Databases primarily go for redundancy. Alright, question 2 is done. Let's move on to NoSQL databases, database categories. Column. Just questions for learning objectives. Describe the architecture of the column-based category of the NoSQL database. Alright, so the architecture of the column-based category, it's So yeah, you can have multiple columns. You can have sort of column groups or families. I'm not sure. Oh no, real column families. Indexes are fine. You can sort of do some. It's very difficult to use like multiple columns together. You can't really use them together, but you can have related columns. It's flexible. You can put any type of row you want in your column. It's not a flat out table that you're just producing, but it is just a column. Yeah. Oh yeah, by the way, also documents can be unstructured. This is unstructured, so you can have any type of row, like a blog post or whatever. And yeah. Okay, so column based. Okay, from big table, clones of columns or wide column databases, or groups of columns. Column families are several rows belonging to one or more columns. Groups of columns are often accessed together. Okay. Accessing the column family not required to share the same columns, can share a subset or none. Can be access or rows not required to the same columns, can share all the columns, a subset or none. Columns can be added to any number of rows or not. So if you want to create a row, I think this is still an JSON object, because it's still, we've been speaking about events this whole time, and if you think about it, that's pretty much very clearly an event. So it just has a key and a value. You can have multiple keys, absolutely, and I would say those are multiple columns. But this is just one column, one key, and then all the values. As far as I see that way. And then it says here rows are not required to share the same columns. Rows, so the rows going this way are not required to share the same columns. So it is very unstructured. Columns can be added to any number of rows or not. Okay, so your rows do not have to be part of another column. So they can be missing values. Okay. Big table, wide columns. Okay, so describe architecture for column based. So it's just basically a whole lot of columns with rows, a whole bunch of rows going down. And I think I don't know, you can't join the columns, but you can create column families and they can be related. The rows can be related, but I still find it very hard to see how you can link them. Maybe if a row has a row. Yeah, again, it's very tricky. Anyways, that's what it is. And it was spawned by Google big table, and it's also called wide column. Alright, so question 2. Explain the primary use cases for the column-based NoSQL database category. Well, a lot. It's very scalable. I'm guessing you can just bring in a lot of data into the columns. So when you want a lot of redundant streaming services like Netflix, right, and not use cases would be when you want to do a whole lot of, when you want to normalize it, because that's just impossible. It's just one column, basically, acting as a table. Okay, so let's see what they say. It's great for large amounts of sparse data. We sort of said that. Being deployed across the cluster of nodes. Okay, like most, by the way. Can be used from event logging and blogs. Okay, so this is another similar one, which is event logging and blogs. I think you can also do that with documents. Counters are a unique case for, counters, that's true. Have TTL parameters, which is useful for data that expires. And here are unsuitable use cases for column-based databases, for traditional ACID transactions, read and writes are only atomic at the row level. So that means it's difficult because the rows are so badly ordered, and rows can be anywhere. It's difficult to read and write to it. Okay, early development query patterns may change and require name row changes to column-based databases. It can be costly and can slow down the production timeline. So what is this? Query patterns, column-based databases, numerous changes to column-based databases. So query, okay. So query patterns may change. So let's try again. Explain the primary use cases for the column-based SQL database category. So basically, okay, so it's good for blogs, it's good for counters, and just waiting for until something counts, until something like a session expires, and then it counts and expires. You can just use that. Yeah, it's good for the other stuff as well, like scaling and partitioning and having it available, I guess. Okay. Also, yeah, TTL expiry. So then there's also big table. Yeah, big table wide column. Not suitable use cases are atomic transactions, read write. Because they have to be done at the row level, and rows are a bit inconsistent. Let's just say that with this. So because you have inconsistent too many rows on one side, too little rows on the other side, the read write displaces everything, and it's just one column that she's putting it into, as far as I could visualize. Also, another problem would be when you have to use a different stored procedure to access and change the documents. That means you have to change the schema. So then, is it such a flexible schema? Not so much if you want to do those. But otherwise, I would say this. Question 2 is done. Let's keep going. We still have quite a while to go. NoSQL categories graph. This is a very unique one. Describe the graph category of NoSQL database categories type of architecture. First of all, it's almost relational. It contains multiple sort of tables on servers, which can get a bit tricky. However, if your structure is graph-like, meaning that everything follows, there's edges, there's relations to everything, all the tables are very related, then graph works very well, and it's designed for very related data, as far as I remember. Scales well, okay, it doesn't scale well. Availability, it doesn't have a lot of availability. Yeah, because you have to store, it gets difficult to sort of back up the data. It is costly, because you have to back up the graphs with entities for nodes. Our database is not shard well. Okay, they're not shard well because you have to traverse. Are ACID transaction compliant? Okay, so the question 1 describe the graph category. There was graph. ACID compliant because they're very close to being relational databases. Explain the proper use cases for the graph in the SQL database category. I think, honestly, it's just money transactions, maybe. Am I crazy? Is it money transactions? And not so use cases are for lots of data because partitions very well. And okay, what is it? Okay, finally related social networking, routing, spatial maps, recommendation engines. Okay, so that is actually for recommendation engines. Doesn't have the advantage of NoSQL databases. Okay. Needs to scale. Okay, needs to scale horizontally. Can't do that. An update is recruitment parameters can be non-trivial. Okay, this type of. Okay, so here it is. So explain the primary use cases. So recommendation engines. I think mapping and not so use cases are when you want to do the schema that you put it in can be very difficult because you have to spread it out, and every node will have to require that schema to have it in the moment in a NoSQL database or server for server, and that partition, and then you have another partition with it. And it has to follow that schema, so you have to keep following it. I think that's what they mean. And storing non-relational data. I'm not sure, was it scaling horizontally? Okay, we mentioned that. We mentioned that. We wouldn't say scaling horizontally. Yeah, because it fills up the space. Yeah. Okay, database deployment options. Okay, module 2, working with distributed data, ACID versus base, question learning objectives. Define what ACID and base stand for. ACID stands for atomic, which means that it has to be done at a specific level, at row level. It has to be perfectly done. Consistent means it must be done over and over again, I guess. Consistent means one change must be affected with the data. As isolated means one transaction done while another is happening can't affect anything. Durability. The transaction will continue to go through. Atomic means it will go through no matter what, even other than a roll up going through. Base, basically available, which means it's available very frequently because of the servers. Soft state means that the data is very flexible, and because it's unstructured and structured data can be loaded. And essentially, eventually consistent. There we go. So, basically available, Okay, substate. Okay. Eventually consistent. Okay. I think that's just bad notes. Yeah, that's just bad notes for me. Okay, question 2. Identify the use cases for ACID and base model systems. Okay, so ACID is for... Wait, what? Okay. Well, NoSQL and relational database? I don't know. Okay, so... Wait, that was so bad. Financial institutions, so ACID, okay. Okay, so if the money, if the money doesn't go through in one system, money isn't connected to another, okay. Do if not credited at all, okay. Alright, interrupt transactions, that's for ACID. Okay, use space for base, worldwide online services need to be accessible at all times, streaming, Netflix, Spotify, Uber, system becomes true. Okay, so now that we know this, identify the use case for ACID base. So basically, ACID, you want it for financial institutions when they're doing transactions. You don't want transactions to be interrupted or the transaction to go through twice, or not go through and then go through, and the person gets incorrectly debited or credited. And for base, you want client-side servers to always have the client receiving what they are requesting, such as their stream data, which is Netflix and Spotify, so on and so forth. Alright. Questions. Oh. Okay. Questions 2. Okay, question 3. Wow. Describe the differences between ACID and base. Jeez. Okay, so ACID is for primarily relational databases. ACID is focuses on, write before read and all of that. Okay, let's just go back here. So ACID model used by relational databases, shows transactions. Okay, let me first make my things here. So ACID, I would say, consists. You want ACID is done when you want your data to be sort of available, consistent. So you don't want available. You want it to be changes to be reflected. You want there to be the relations. You want there to be a fixed schema, and you want specialized people to work on it for analytics. So for business operations, it's generally done with data warehousing. Okay. Data warehousing. Base, you have a lot of availability, you have a lot of data, scalability. The servers are distributed in clusters, nodes, horizontally scales. Data eventually becomes, after a while, somewhat consistent. But in terms of the big ACID consistent type of consistent, and but your goal is primarily to get data to servers. So let's see what it says. ACID model used by relational databases ensures transaction is always consistent. Used by financial institutions, data warehouses, writes data easily from many small transactions. Best for relational databases, data integrity ensures full consistent system. One data tables reflected constantly. While the table base model used for NoSQL databases, no requirements for consistency, benefits variable scalability, resilience. Okay. Used by marketing and curfew settlement competitors, social media apps, worldwide online services. As long as you can get your data request to as well managed, that's very important. This is not as good as a base. Okay, so basically, ACID is when you want lots of small transactions, such as financial institution transactions, very important. And basically, everything else I said, and obviously, reliability, I suppose. Distributed databases describe the concepts of a distributed system. Okay, so a distributed system. Wow, there's a lot to say on that. It's many servers connected natively or across different points, like on the globe maybe, and they all contain data relating to a specific topic, and this could be in a NoSQL server. So the NoSQL data, and they could all be NoSQL database servers. And generally, if one goes down, well, they could be stored in replications, partitions, and so on and so forth. yeah, one goes down. They generally do scale well. Yeah. Okay. Next one, distributed. Different locations, fragmentation of servers. Okay. Okay, and SQL follow the base model. Okay. Question 2. Define fragmentation and replication of data. Fragmentation is when the partitions are stored on the servers, and then those servers all have those partitions either updated one at a time, which also shares the load of the data, which allows more scale, more data to be there. Replication. Replication, you just copy the data onto multiple servers. I don't even know, maybe even multiple, yes, you could even copy the servers with the nodes onto multiple database servers or nodes, and those just create a copy of a server, a copy of a node, and if one goes down, you can use it. Now this I'm fairly certain I'm right on, but I will check anyway. There's a large amount of data on your distributed stream to break fragmentation into partitioning. Partitioning fragmentation, each partition is not big. Store and replicated partitions. Synchronization of data. Synchronization, okay, so replication. There we go. Question 3. A sort of case of redundant data. Okay, so let's move on to question 3. Describe the advantages and disadvantages and challenges of distributed systems. Obviously, an advantage of a distributed system is availability. There's a large amount of data and it's available all the time. Once the server goes down, you can go use it for maintenance, because of course you have a replicated server you can use it with. And more advantages. Clients always have access to the data. That's as far as I know. It's just that's the primary thing. Here, I'm not actually sure. Challenges. Bad synchronization of data. One bad, read or write, and problems can occur. Because it affects all, it's rewrited to all of them. Let's see what they say. Advantages of distributed system: reliability, accurate, independent, improved performance, no need to worry about. Okay, so you don't have to worry about conforming to the schema. Restrictions or data type, query process time reduced. Key relationships are less. What is this? And slow. Query process time reduced. Okay, whatever. Ease of growth scale can handle very large amounts of data, but by, for example, handling or shuttling the data across multiple servers. Continuous availability. Data crashes, you can lose another one of the main source in a server. So those are the advantages. Challenges of distributed system consistency while replacing large amounts of data through replication. And the database is getting many reads or writes. The synchronization could be incorrect data. Write, go to all nodes, have problems. Through all those, very little support for events. Well, the database actually is manual to read the process. Okay, so to re-answer it again, describe the advantage challenges. It's apparently mentioned reliability. They also meant improved performance because of queries. Easy queries, flexible schema. So flexible schemas comes up quite frequently with document and actually, document's flexible. I think key value is less flexible, but still is flexible, and of course, column is also very flexible. So in general, NoSQL, except for graph, is Now I wouldn't say graph is flexible, right? Graph isn't flexible, right? Graph isn't flexible, right? versus if this is compliant, I mean obviously it's flexible. Yeah, obviously it's flexible. If this is compliant, obviously it's flexible. Alright. Let's keep going. Question 3. Oh yeah, must do the challenge. All the challenges we got right. So okay, now we have the cap theorem. Now this yes, this is me. So defining the cap theorem. The cap theorem, yes, it's consistency, availability, and partition tolerance. So, oh wait, I just want me to do that. Okay. Okay. Multiple. Okay. States there are 3 required. Okay, so there are 3 states required when you're deploying, implementing the hardware software design. Yeah, but this is obviously not DBAS. Anyway, so okay. Yeah, I don't know what else to say. That is question 1. Okay, question 2. Describe the characteristics of the cap theorem. Consistency is purely relating to the nodes, right? It's just like the visibility of the nodes. And I think the keys, so that you can just see the keys. And all the values, the key and the values. If you can just see that, and consistency, what is it? Consistency, I think if that's what it refers to, then making sure that you can always have the data, making sure that the data is correct, I guess. Is the system running smoothly? All the nodes connected for clients to be able to process at will. Okay. The nodes contain servers and clusters, also known as a server network. If these servers are connections to speed and synchronization, okay. 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 Alright, so wait, I didn't even do all of them. What am I doing? So availability is availability is, so can they get the request to the client, all the servers up and running? Yeah, surely that's just it, right? Okay, preventive accidental deletion, I completely forgot about that. Requesting the data, okay, so that is what I said. Server location, okay. So availability, yeah, start requests, but then there was one, oh wait, I'm reading it again? So bad of me, so bad. Of a SQL file or data accidental deletion. So availability in case of accidental deletion, you can use it. Alright. And then partition tolerance, I think that's just having like the 3 servers and making sure they all have partitions and using the partitions. Yeah, partition tolerance, I think I've done badly here. Okay, so the partition tolerance, placing a node or partition. Okay, so basically, let me sum it up. Consistency is relax. It's just, can the client see the nodes? Is the data synced correctly? Is the read-write correct? Then availability is the request correct? Can it be backed up if something happens? And then partition tolerance is, okay, if a node fails, is there another node just to connect to it? Is there a break? Is there no chance of a break in partition if the connection between the partitions, which is the connection between the servers, or the connection between the databases, which share all the table, which share all the events, the documents, and the MySQL data, and or graph or column or key value. So it's just essentially the resilience. Okay, yeah, I think that question is overcomplicated. It's like way out of this world overcomplicated, that question. Jeez, okay. Yeah, whoa, dude. It's not even that complicated. Describe the history and relevance of the CAP theorem. History of the CAP theorem in the two. Oh wait, what am I doing? Describe the history and relevance of the CAP theorem. Okay, so yeah, as I clearly saw there, it comes out in the 2000s. I think it was this guy, Eric Pennyweather, Eric Spiritweather or something, I don't know. And then Nancy Lynch and why do I remember? I think I even remember the other guy. And Albert. Okay, I don't know. What was his name? What was his last name? Anyway, they're both from MIT. They sort of refurbished his theorem. And yeah, it came about because of the need for big data, I think. And what else? Describe the history. Oh, the relevance. Okay, the relevance. Well, the relevance of the CAP theorem. Yeah, well, when you're considering creating a database and you want to either host it or if you want to do the hosting, the hardware, the software, and the design by yourself, I definitely consider the CAP theorem, because the most important thing is for clients to get, when they request something, say stream, they get the stream back to them. That probably could be in a column form, I'm guessing. I think it could be column or document, to be honest. I'm dead serious. But yeah, you just have images. Yeah. So essentially, that is something. See. CAP theorem is what's the CAP theorem? Oh yeah, there's the answers to the question as well, which I also know, which I should probably use. So the answer to the question is you have availability, you have partition tolerance and availability, or you have consistency and availability. Consistency basically means your synchronization of the data. You want it to sync correctly and it's visible. So if you're using that part first, then it's the next part can come later, and then partition tolerance is you just want the data just to be given. There's no need to worry about, there's a slight need for read write, but that can come later. So essentially, that's what. There's a few things. Okay, Hadoop. Introduce the architecture. Requests Eric Brewer, Seth Gilbert, and Nancy Lynch. Eric Brewer A, Seth Gilbert, and Nancy Lynch. Relevance of CAP theorem, partition tolerance, consistence, MongoDB, data integrity can be used, partition tolerance strategy. Availability, of course, it is a column-based and a SQL database, actually meaning it is used primarily for creating database columns. If consistency cannot be primary most relation. So what does Cassandra want to do for us? Cassandra looks for availability. Cassandra looks at availability. Mongo looks at changes, partitions. consistency of the server. Yeah, I really overcomplicated it once again. She said, I definitely need to get better at that, but of course I've never really studied like this, so I just don't know. Okay, this I think is the last one. Challenges in monitoring in mitigating from RDBMS to NoSQL database questions or learning objectives. Describe in which cases RDBMS and NoSQL are best used. RDBMS is best used when you want a lot of relations, consistent transactions, you want changes to be reflected. If you have a lot of small transactions, you should do it. If you want to work with structured data, of course, which is consistent, which has like a consistent, and you want to work with a consistent schema. You want to have business intelligence analytics, and you also want to have a very, very specific use case. Or you want to have a very, very fixed use case. That doesn't change. Okay, and then you want for NoSQL. For NoSQL, it's okay, so when you want a very flexible schema, you don't have to worry about the schema. You want your data to always be available and to be you don't have to worry about the consistency of the data itself. And or you want the best of both worlds, and you want it to scale well. You want to handle lots of data at good speeds because of many servers using clusters of servers. If you want to scale, if you want scale horizontally, if you want to store large amounts of data, if you want to stream. All right. Okay. What's for both? It didn't say. Cases based for RDBMS, you want to documents, consistency, cases for NoSQL need to appease the client request, so need scalability, need availability. Large amounts of data you need to want to be flexible with. Okay, well, cases are achievable for using both NoSQL. And you want scalability and storage and high performance. So scalability and high performance, however you want to be able to do many read or write transactions and documents in the database, and you want to do complex join of transaction tables. Very, very nice. All right, so yeah, you want to do both of them. Yeah, I didn't really, that wasn't the question. Describe the main differences between RDBMS and NoSQL. Are you kidding, right? Okay. Really? Okay. One's unstructured, one's structured. One's, non-relational, one's relational. One has atomic transactions, one is base transactions. RDBMS is run where you want really one server, and SQL is run on quite a few servers, partitioning, scalability, availability. I mean, what is the answer? Now, SQL accessing data is the most important than whatever that data may be. Yeah, I guess it's true. Sometimes interviews may be relevant containing data you may want to analyze. So yeah, again, analyzing, I guess, and server the data. They didn't necessarily require scalable data, similar value consistency. Okay. So based on how the model can work with the data and the database. Most data can be mapped to complicated fragments and many support table joins. Yeah, there's that. So it doesn't support joins and yeah, so NoSQL does relational database support joins. That's the only reason, right? Oh my gosh. Oh my gosh. Alright, let's do this. Alright, let's do this. Am I still streaming? Probably not. Probably not. What are the four main categories? Key value, document, column, graph. Wait, isn't just this? Okay. What is the name of the fully managed service model that databases servers? What is the most common trait among NoSQL databases? Well, that's not. I would rather say that. Okay, so which formats are typically used for documents stored in a document-based NoSQL database? Oh, that's easy. That's just this. It is recommended not to show data on. Probably this. Okay. Let's go to this. Okay. Nice. Very nice. Okay, so got one thing wrong. Yeah, this one was yeah. I suppose they are all non-relational. I mean, that also would be a thing. Okay, so we want to get it graded here. Let's do this properly. Okay, here we go. What common trait does not share? They're non-relational. What may be the most common reason to use a NoSQL database? Probably scalability. Oh, there's this. It's definitely not consistency. Oh, wait, we know what it is. Wait. We know what it is. Scalability is, yeah, okay. Because cap is there, so okay. What makes key value NoSQL databases powerful for basic CRUD operations? What? They're not atomic. They are represented by a hash map. That's what. Huh. They shard easily across nodes. Okay, well, CRUD operations are create, replace, I think, and update and delete. And yeah, if this were true, I would click it, but they're not. They're not, right? They're not, right? This is true. This is true. They shard easily across nodes. Okay, that does make sense. Okay, well, what use case would be a poor choice for a document type? Wow, document type. Probably atomic transactions or something. Aggregate-oriented design. Operational data sets for a web app. Okay, definitely not this. Definitely not this. This doesn't make sense. Because I kind of have prior knowledge for that. What is the characteristic of a column-based NoSQL database? What is the characteristic of column-based NoSQL databases? Column-based. Okay, so columns are grouped together in families because they're often accessed individually. Rows and column families are required to share the same columns. Rows and column families share all, a subset, or none of the columns. Oh wait, isn't it columns? Rows and columns are required to share the same column. That's not true. Key or identifier, that is not true. Not always true. Columns are grouped together in families because they are often accessed individually. Well, that doesn't make sense because family accessed individually. Well, those two are like oxymorons. So this does seem reasonably true. Okay. I definitely got this right. This one I might have got wrong. This one I might have got wrong. This one I also might have got wrong. Yeah, that'll be insane. Again, it's not about the market all for me. But maybe I can get a bit mark here. I feel like this is somewhat makes the most sense. It's either this or this. They're not atomic. I remember being told they're not atomic. Scalability. I remember that from the videos. So again, I could argue I gave the answers I believed to be correct. So we got 60. Okay. Aggregate orientated design. Aggregate orientated design. Yeah, I remember that, so I should have said that at least, but this. Okay, well, actually, I have an idea. Oh, wait. Here. Here, okay. But I just want to try. Just want to see if I can get it right. Okay, here it is. Let's try again. It won't be the same questions, right? It is. Scalability I actually got right. This one and then this one. Okay. Now if I whatever I get here, yeah. If whatever I get here, yeah. Okay. Yeah. So what was the one that was wrong? Oh, basic CRUD operations. Value is opaque. The value blob is opaque. Again, I don't understand. This is just lack of understanding, really. Very poor for me. Very poor. Let's go to the practice quiz for working with distributed data. What is one way the distributed NoSQL database usually shards data? By grouping all keys numerically, by grouping all keys lexically. Usually stores data. Oh yeah, by grouping all keys lexically. By grouping all keys lexically. Why does this one sound so right? By distributing all records that share the same key across multiple servers, by grouping all records that have the same data on the same server, but then again, we've seen this, so we should get it, right? We've seen this, so we should get this, right? So, which requirements, that's A to Z, which requirement would prompt you to consider choosing RDBMS over NoSQL? High availability, flexible schema within complicated joins. Yeah, flexible schema. Yeah, because if you're choosing it over it, that means you're choosing it. So, what requirement does the base model support? Eventual consistency. What is the best way? There's only 4 here. What is the best way to describe the partition tolerance characteristics of the CAP theorem? The system continues to operate despite data loss or network failures. Okay. The system continues to operate even in the presence of node failures. Okay. All nodes within a cluster see all the data they're supposed to at the same time. And the last option, the cluster must continue to work during communication breakdowns between nodes in the system. Okay. One of them has the word communication. This one I like because it has the word communication in it. Despite data loss or network failures, see the data they're supposed to. Oh wait, we didn't even do this. We didn't even do this thing properly. Oh my gosh, we didn't even do this thing properly. Oh my gosh. Yeah, I just realized we've completely skipped the actual other learning objectives as well. Oh wow. Okay, so before we have to let's do that as well. So hang on. What is one way that a distributed NoSQL database shards data? Lexically feels right. This one's definitely right. This one is definitely right. Must not continue to work. Okay, so that's wrong. Data continues to operate even in the presence of node failures, despite data loss or network failures. Okay, that is a bit easy to operate in. Yeah, that's easy. Node failures doesn't make sense. All nodes in the cluster see the data. That's just consistency of node failures. Okay, so that's that, right? Isn't this correct? How much of even in the presence? Yeah, let's see what we got. Okay, we paused, but we got one wrong. Okay, wait. Oh no, way did we get this one wrong? We actually got this one wrong? It's insane. Wait, it is more to do with another characteristic. Despite data loss, this is not a way to describe partition tolerance. Node failure. Oh no, that's that's different, right? That's resilience. That's completely different. That's resilience. Partition tolerance is just so it is that. Okay, let's do the last one. But before we do the last one, let's actually complete the week. Okay, question 2. Explain the character. Explain. Wait, what? Okay, explain the characteristics of NoSQL databases as scalability, flexible schema, availability, partition tolerance, I guess would be one of them. Sharding, they have. They also have flexible schemas, I guess. You have high performance because everything's running concurrently with the servers. You have horizontal scaling. Yeah, that's that. Okay, list the 4 main categories of NoSQL databases available. Okay, we know column, graph, document, and key value. There we go. Describe the key value of NoSQL document database category and its architecture, including its architecture. Describing the NoSQL database category, including its architecture. Okay, so key value is atomic. well, it's apparently good for CRUD operations because of its that it's hashed for the values are safe. When you're creating a table, you can create safe values for the table, I guess. Has a flexible schema. Okay, it has all the main features of a NoSQL database. And what else? What is sort of key value or sort of hashed? I mean, that's all it is, really. Yeah, you can't perform complex queries on it, but everything else is normal. Yeah. Describe the column-based NoSQL database category, including its architecture. Column-based. Okay. Okay, column-based is just the same again, except it's just one column, and it can have rows. You can have column families. You can also group the rows into a subset. The subset doesn't always have to be part of the column. There's that. Describe the column base. Okay, so there's that, and including its. I'm trying to find out what else there is. Yeah, it's JSON, XML documents, good for event blogging, and I don't know. Blogging, yeah, event blogging is a familiar theme. And counters and TTL expiries. Describe the NoSQL database documents. NoSQL documents. So columns are just columns. All of these are key values sort of in JSON XML, and each of them are events. They can be actions. This is blogs. Sort of similar. Once again, it's very difficult to relate them, but you can create collections of columns in the database. Next, explore the NoSQL graph database category and contrast it with the other three database categories. It's the only one that has atomic transactions, the only one where you can do quite good queries, and it breaks up all your sort of your events or your key values in that famous curly bracket for system, and just puts them in different shards, which can be difficult to traverse and get. Define database as a service and describe between available hubs. So database as a service is different from do-it-yourself and hosting, because you just do the design. You don't have to worry about the hardware, about the software. You don't have to install the software. Like, I think you have to install the software with. You get given the hardware for hosting, but you have to install your software and do a whole lot of admin. And it removes all the effort. You can just do designing applications and so on and so forth. Question 9. Discuss the differences between ACID and base operations. Okay. So one of them is about data integrity. The other one's base operations are primarily to do with large amounts of data, and are generally scaled large amounts of data. ACID operations are obviously done primarily on relational databases, based on SQL databases, and I'm getting tired to speak. Alright, question 10, summarize the advantages and challenges of distributed systems. The advantages and challenges of distributed systems. Advantages of distributed systems, basically everything to do with NoSQL, scalability, flexibility, flexible schema, oh boy, and partition coding and all of that stuff. and speed and performance, but the challenges are, of course, keeping the data consistent and synchronizing the data, making sure it works. And the advantage is obviously the goal is just to get the server, this client server request. Challenges with distributed systems. One fault could lead to a whole lot of other faults. There's not many challenges actually. Can't really. What other challenges are there? No atomic transactions. You can't do complex joins. There's not much challenges. Distributed system. It's not costly. I don't know what the challenges are. The differences. Oh wait, what do you mean? Just define the CAP theorem and describe its characteristics, consistency, availability, partition tolerance. Consistency is just synchronization. Availability is just make sure it's always available. Partition tolerance. If there's a network failure or breakdown between nodes, the system continues running. And identify the best cases in which to use RDBMS and NoSQL. RDBMS is best used for financial institutions when there's lots of incremental small transactions being done, and it's best in case you need atomic transactions. You want to have complex joins. You want to have specific data. You want to have analytics data. Very specific analytics data. Company wants you to use it. And for SQL, probably the World Wide Web services, and the client wants it to be available. I mean, you can definitely say Spotify and Netflix and YouTube, or definitely using NoSQL databases because of their availability, scalability, and all that other stuff. I'm sure I don't need to say it again. All right, let's keep going. Repeating. Interesting. Isn't it this? Isn't it this? Okay. So we paused, which is good. Okay, it must be this one then. Wait, what? This is the one I thought? Are you joking? Are you joking? Oh, sorry. Oh, what is... the query's in the way. The data. Oh my word. Okay, so it's not high data is denormalized. First of all, it very rarely will be normalized. Okay, let me try this one more time. Hang on, how do I try this again? Try this one more time. Yeah, I want to get this. Post. I have to post. And it's this one. Yeah. Let's see. Oh wow, still 75. This is insane. We keep pausing, which is good, but what is this? Like, this is terrible. what drives your model in NoSQL, your data model. Your data model. I did look at this question the wrong way, though. What drives your data model? How the data is denormalized. So denormalized just simply means how the data is denormalized. How the data is denormalized. Well, normalized data is redundant data in multiple tables. So it can't be that. Okay, well, surely it can't be the way the data is denormalized. Otherwise, I just don't have a clue what denormalized means. Do I just not know what denormalized means? Okay, but we're not making progress, which is not good. What drives your data model in NoSQL? How the data is denormalized. Denormalized. It's not normalized. So normalized data, you have duplicates. Well, surely that's usually relational databases because then you care about like the duplicates. Okay, I'll give one more answer. Otherwise, I'm not. Oh, wait, hang on. I don't know. It's auto gen me. Hang on, let me go back. It auto remove me from that spot. Let me go here. Okay. I want to do one more. Let me do one more. Financial institutions. Replicating data across all nodes to this could be. Wait, but it can't be. Yeah, it can't be. Yeah, so I'm saying it can't be. So let's see. Can't be, right? Oh my word, it is. Crazy. Oh wait, it is right. Okay, that doesn't matter then. So this is yeah, we're passing, that's fine, but oh wow. I guess the driver model should be based on how the app interacts with the data, or rather how the model can be stored as rows in one or more tables. Your queries and the way the app accesses the data. So basically the queries you're using to access the data. Because your queries don't come first, the data comes first. So after you've got your data, which is, as they say, you're looking at your data more. Okay, that's definitely one for the books. One for the books. All right, let's move on to the next item. Right topics. I don't really know. Is there any that doesn't apply here? This is all a bit overwhelming. Okay, so we've done this. We just need to do this. Oh no, we've done this. Yeah, we did the summary and highlights. Mark is complete. Okay, good. Now we move on to CRUD. Wow. Okay. Course 10. Week 2. Module 2. Getting started with MongoDB. Getting started. No, it doesn't get me down because I paused, so it's no real error, but I am upset that I got that one wrong. I have to make up an understanding for that now. So my understanding for that is once you get to modeling your data, because you've already got your data, then you start worrying about the queries, because then you know you're on the data model. I think it's difficult to sort of understand. Yeah, you got to study properly before you can get these nicely. Alright, let's go here. Oh, is the speed still? Oh, the speed still set at that. You know what? Let's leave it at that. It's fine. Is autoplay off? Yeah. Autoplay, no. Good. Alright, this is CRUD operations. Fairly standard. Fairly. Hang on. CRUD. What is going on? I'm sorry. Hang on. Let's go here. I don't know what's going on. Can't seem to get this thing to work. Okay, so it's just those. Hang on. Okay. Okay, there we go. So we have questions or learning objectives. Okay. Okay. Question 1. Objectives of learning this video will be able to. Question 1. Use Mongo shell to connect to a database. Use Mongo shell to connect to a database. Thing is, it's very important to realize that everything builds on everything else, so you've got to constantly be linking everything together. Perform basic CRUD operations. Question 2. CRUD operations. Alright, here we go. Here are the questions. Let's get started. Week 2's sort of... Week 2 has its thing, right? It's questions, right? Alright. Okay. Getting started with MongoDB. Questions. Okay, question 1. We have a 6-minute video. I need it to be bigger. Actually. Alright. Alright, there we go. Okay. Okay. Mongo shell interact with MongoDB, okay. Okay. Mongo shell, okay. Data and administrative tasks, okay. Connection string. Okay. Okay, wait. So first we connect to our cluster by... Okay, we connect, and then it shows up like this. Okay. We can view the list of our documents, okay. Okay. I actually don't know what they mean by write this down. Okay, let's keep going. We can view the list of the documents. For simplicity, we'll assume, okay, it's already connected to our MongoDB instance. Okay, so we're going to assume, okay. Set database context. Start working on the campus management database. We run the following statement. What do we run? Use campus DB. Okay, so this is created. Okay, now it tells us that we switch to it. Okay. It shows two collections. Wait, are we meant to remember this thing here? Are we meant to just remember this? Wait. We're meant to just remember this. MongoDB. User password URI test. A connection string. Okay. So MongoDB : two forward slashes user password at URI test. Okay, very good. So now it says show. What is this? Didn't we just do this? Okay. Show collections. Okay. Create. Okay, now we want to create, right? Oh, connect to a database. So question 1. Oh, you want me to? Okay, so it's what is it? Wait, hang on. Let's go back. Okay, so we want to connect. So we need to connect. Okay, so we connect by going Mongo. What is the next thing? Okay, MongoDB. So now we connect to the database. As follows: forward user password at URI test. Okay, so you want to focus on your queries with data. I think you always want to focus on your queries with data model, to be fair. Okay, so this is question 1 is done. And then question 1 is like done, so yeah. Anyway. I think there's nothing I can really do here. Am I hungry or what? Jeez. Did I say that? Yeah, this is not how I feel when you're not on it. Alright. Oh, okay. Let's keep going. Let's get this done. Okay, so we've done that. I don't even know if we're live. I should probably check. Okay. It shows two collections, staff and students. CRUD operations are create, read, update. Sorry, create, read, update, and delete. Okay, so let's go here for create and delete, hence the acronym CRUD. Let's start with the create operation. Okay, alright, so this is a create. Insert 1. DB students insert 1. Okay, so this is insert 1. So we're starting with only DB here. Okay, so this is a insert 1. And if we insert 1, it will show us this. But they just but I remember it's insert. Isn't it insert? Okay. Into the collection. And this is the output once it's been put in. Okay, let's keep going. So wait, sorry, I missed that. Okay, wait. So go back. Takes the form of a DB, campus management DB database. Okay. That's our database, that's our collection, that's our create statement. Let's keep going. Just students, and then the insert 1 function. Also called a method. Well, it's called functional method. This function which takes an argument as the document which we want to create in the students collection. The outcome is an acknowledgement that the operation was successful, and it also shows the inserted ID, which is this, of course. Document, a required field on every document in MongoDB. Okay. Yes, this is a required field. Because we didn't provide one ourselves in John Doe's document, the MongoDB shell driver will add the ID field and generate the object ID for us. So object ID. Okay, so if we put in an ID field, it would create a object ID for us. Okay. Mongo shells the JavaScript interpreter. Let's keep going. It is Mongo shells the JavaScript interpreter. Makes sense. Create many. Meaning you can define variables and perform other functions in it too. So create many. Okay. Students list equals passes 2 documents in it, and of course we know that JavaScript is array. But anyway, actually let's rebroadcast the stream.